Hi, welcome to 1.2 on acceleration. Let's start with some definitions. Position, remember, is the relative location of an object at any given time. Distance is how far an object has gone. Speed is how fast an object is going. Velocity is that speed and direction included. And acceleration now is a change in velocity over time. So there are three ways that you can accelerate something. You can speed it up, you can slow it down, or you could change its direction. Remember those ticker tapes? The top object is moving fast. The second object is moving slow. The third object is moving at a moderate speed, but all the top three are a constant speed. The bottom two are showing acceleration. The dots are getting further apart in the ticker tape or in the motion diagram. That's acceleration. You're going to want to add the following to a formula sheet. Acceleration is a change in velocity over time. Time is a change in velocity divided by acceleration, and a change in velocity can be found by taking the acceleration times the time. V is velocity. It's in a mixed unit. Meters per second, miles per hour, feet per minute. Time is a unit of time, and it is measured in seconds, minutes, and hours. Acceleration is the letter A, and it is in meters per second, or miles per hour per second. The delta, the triangle, stands for change in, and it is the Greek letter delta. Velocity units are a mixed unit. They are a distance over a time, and acceleration units are a double mixed unit. They are a distance over a time over a time. So problem one, a car accelerates from stop to 60 meters per second in 6 seconds. What is the car's acceleration? Again, we want that EY, equation work answer units. Acceleration is a change in velocity over time. 0 to 60 is a change of 60. Divided by 6 would be 10 meters per second per second. In problem 2, car is traveling at 60 miles per hour, slams on the brakes to avoid hitting a deer, and comes to a safe stop in 6 seconds. What is the car's acceleration? Well, this time notice that the change in velocity is negative because I'm slowing down. So it's a negative change in velocity of negative 60 miles per hour in 6 seconds, giving me an acceleration of negative 10 miles per hour per second. Position, velocity, and acceleration graphs. These are going to be curves. And when you look at an XT graph that's not linear, it's not a straight line, you really kind of have to zoom in and look at the slope, because remember that's what velocity is, the slope of an XT graph, at a given time. So look at the red line moving back and forth. The red line is showing the slope of the blue curve at the green dot. So a pencil can be used as your red line on your graphs. We're going to look at these 4 questions when you look at a position, velocity, and now acceleration graph. What is the starting position, positive or negative? What direction is it going? Again, positive or negative. What is the starting velocity? This will be positive, negative, or even 0. And then what is it doing? Is it speeding up or slowing down? This class will not deal with changing direction. Speeding up is only if its starting velocity is 0. Otherwise, it's going to be slowing down. So the ultimate description combines those 4 answers to kind of write a description of what the object is doing. So let's look at example 1. In this problem, right, if you look at the slope of the line at the top, it would be 0, and the slope at the line at the end would be negative. So we could draw a VT graph going from 0 to negative. Then the slope of that line is negative, so its AT graph would be negative, just like it was if it was flat. So looking at the overall description, the starting position was positive, it's going in a negative direction. Its starting velocity was 0, so it is speeding up. So the ultimate description is this object is speeding up in a negative direction. Number 2, given this curve, it has a 0 velocity to start because the slope is 0 at the beginning. The slope is positive. It's pointing up at the end, going up from left to right. So we would draw a VT graph going from 0 to a positive. That slope of that VT is then positive, which makes that AT be a flat line above the t-axis. This has a starting position of 0, is going in a positive direction. Its starting velocity was 0, and it is speeding up. So the ultimate description would be this object is speeding up in a positive direction. Number 3 looks like this. Notice the slope here is negative, and the slope at the end is 0. So we would draw negative to 0 on our VT graph, because to get from the xt to the VT again, you find the slope. The slope here is positive, so we would draw positive on our AT graph, and writing our description, looking at our 4 qualifying questions. The starting position was positive, it's going in a negative direction. Starting velocity was negative, so therefore it is slowing down. Object 3 is slowing down in a negative direction. Finally, this is object 4. Object 4 has a positive slope to begin with and 0 slope to end, so we would draw positive to 0. That slope of the VT is negative, so we would draw a negative AT. Answering our 4 questions, the starting position is 0, the direction is positive, the starting velocity was positive, and this object is ultimately slowing down in a positive direction.